Assalamualaikum. Today we would like to talk about polymer. Polymer are very large molecules made up by many smaller units called monomers, which are joined together in long chains. We can find polymer everywhere around us, in plastic, bottles, rubber tires, clothes, and even in our bodies, like proteins and DNA. Polymer can be natural, like silk and cellulose, or synthetic, like plastic and nylon. They play a very important role in our daily life because they are strong, flexible, and lightweight. I hope by the end of my presentation, you will have a better understanding of what polymer are and why they are so important in modern life or in construction. Assalamualaikum, my name is Dani Hakim Abdullah. My metric number is 2024253552. I would like to talk about the difference between natural polymer and synthetic polymer. See you in the next slide. Next, I would like to talk about natural polymer. Natural polymer is a large molecule made up of repeating smaller units called monomers. They are found in nature. These polymers are produced by living organisms, including plants, animals, and microorganisms. Unlike synthetic polymer, which are man-made, natural polymers are biodegradable and environmentally friendly. For example, cellulose, the most abundant natural polymer found in the cell wall of plants. It provides strength and structure to plants and is used to make paper and textile. And another one is natural rubber, obtained from the latex of rubber tree. It is elastic and used in tire, glove, and many other products. Advantage of using the natural polymer is, the first one is biodegradable. They can break down naturally without harming the environment. The second one is renewable, derived from natural source that can be replenished. And the last one is non-toxic, generally safer for human health and ecosystem. Natural polymer are usually used in various fields such as medicine, food packaging, textile, and even in making eco-friendly plastic. What about synthetic polymer? Synthetic polymer is a large molecule made up of repeating units, monomers, that are artificially made by humans through chemical process. Unlike natural polymer, which are found in nature, synthetic polymer are produced in factories and laboratories, usually from petroleum-based raw material. For example, polyethylene, one of the most common plastic used to make plastic bag, bottles, and containers. And another one, nylon, a strong and flexible synthetic fiber used in clothing, ropes, and fishing nets. Okay. The advantage of using synthetic polymer is it's versatile, can be designed with specific properties. The second one is durable, long-lasting, and resistant to most chemical. The last one is lightweight. It's easy to transport and handle compared to metal or glass. The advantage of synthetic polymer is it's non-biodegradable. Most synthetic polymer do not break down easily, contributing to environmental pollution, especially on plastic waste. Second one is dependence on petroleum. Many are made from non-renewable fossil fuels. Synthetic polymers are widely used in everyday life, including in packaging material, household goods, automotive parts, electronics, medical device, clothing, and sportwear. That's all from me.
Hi, my name is Muhammad Fadlisha bin Muhammad Indrisha. My matrix number is 2024274738. So I want to talk about the structure. Based on structure, we have linear polymer, branch polymer, and cross-link or network polymer. So Linear polymers consist of long straight chains of repeating monomers without side branch like a string beads. Their structure allows tight packing, making them strong and giving them a higher melting point due to strong intermolecular force. For example, high density polyethylene or HDPE. HDPE is used of making water pipe and even some toys. Next, we have branch polymer. Branch polymer are different from linear because they have side chains attached to the main chains. These side branch prevent the polymer chains from packing tightly together. As a result, branch polymer tend to less dense, softer and more flexible compared to linear polymer. For example, low density polyethylene (LDPE). This type of plastic we often see in plastic bags and squeeze bottles. So the last one is cross-linked polymers, also known as network polymers, have a very different structure. In this type, polymer chains are interconnected through chemical bonds, forming a three-dimensional network. This cross-link act like permanent bridge between chains, preventing them from moving independently. Because of this three-day network, cross-linked polymer are very rigid, hard and heat resistant. For example, bakelite, and another example is epoxy resins. So that's all from my part. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Yusri bin Rosli. So I want to talk about polymerization mechanism. Polymers are everywhere, from the plastic bottle we use daily to the material in our cars and electronics. But what are exactly polymers and how are they made? Today we explore one key type, addition polymers. Polymers are large molecules formed by repeating smaller units called monomers. Addition polymers are created when monomers add together without producing any byproduct. For example, polypropylene used in packaging and polystyrene used in disposable cup are both addition polymer. The process is simple but powerful. Monomers like propylene and or styrene link up in long chains through chemical reaction. Now, let's look at some properties. Addition polymers can vary in composition. Some may include natural gas or organic components, affecting their texture, strength or flexibility, while the specific depends on the monomer used. The key takeaway is that no byproduct are formed, making addition polymerization efficient for industrial production. From everyday plastic to advanced material, addition polymers play a vital role in modern life. Next time you hold a plastic item, think about the sign behind it. So next is condensation polymers. Not all polymers are created the same way. While addition polymers link monomers directly, condensation polymers form through a reaction that release small byproduct like water or methanol. Let's dive into how they work. Condensation polymers are made when two different monomers react, kicking out small molecules like water. Classic example include nylon, used in fabric and ropes, polyester, found in clothing and bottle. This process is crucial for creating strong, versatile material. These polymers often have unique properties like nylon strength or polyester resistant to wrinkles. Some condensation polymers are even derived from plant-based material, making them part of sustainable innovation. From your closest to industrial gear, condensation polymers are everywhere. But remember, their production create byproduct, so scientists are working on greener methods. Next time you wear polyester, think about the chemistry behind it.
Hi, Assalamualaikum. My name is Syaful Alshah bin Syari. My metric number is 2024292466. Now I'm going to present about polymer, thermoplastic and thermosetting. Before we dive into thermoplastic, let's quickly understand what polymers are. Polymers are long chains of repeating molecules called monomers. These chains can behave differently based on how they structure: flexible, rigid, stretchy or strong. Thermoplastic are a type of polymer that soften when heated and harden when cool, and this process is reversible. That means you can heat them, mold them into a shape and then reheat them to change the shape again. This property makes thermoplastic incredibly versatile and recyclable. There are some key properties of thermoplastic. First, recyclable. It can be remelted and reused. No chemical change during molding. Lightweight, durable and resistant to chemical and water. These features make them useful in industries like packaging, construction, automotive and electronic. There are some examples of thermoplastic such as polyethylene used in plastic bags and bottles, polypropylene found in food containers and automotive parts, polyvinyl chloride used in pipes and cable insulation. Each has unique properties depending on how the polymer chains are arranged. Thermoplastic are processed using various methods. First, injection molding for making toys, containers and car parts. After that, extrusion for pipes, films and sheets. Lastly, 3D printing for prototypes and even medical implants. So, the ability to make and reform makes them ideal for fast, efficient manufacturing. And now, thermosetting polymers. Thermosetting polymers or thermosets are a type of plastic that once cured or hardened cannot be melted or reshaped, unlike thermoplastics, which soften when heated. Thermosets undergo a chemical change that locks their structure permanently. Thermosetting polymers are known for their high thermal stability, excellent dimensional stability, resistant to deformation, strong chemical resistance. This makes them ideal for high-performance applications where durability is crucial. There are some examples of thermosetting polymers. Firstly, epoxy resins used in adhesives, coating and composites. Second, phenyl formaldehyde used in electrical insulators and kitchenware. Lastly, melamine formaldehyde found in laminates and dinnerware. How polymers thermosetting are made. Thermosets are formed through a process called curing, which involves a chemical reaction, usually heat, pressure, or a catalyst, that creates cross-links between polymer chains. Once cured, the network is irreversible. Lastly, application. Where do we use thermoset? First, we use it in electronics, such as circuit boards and insulators. Automotive, brake pads and engine parts. Then, aerospace, composite structures. Lastly, construction, adhesive, coatings and pipes. Their strength and heat resistance make them perfect for demanding environment. That's all from us. Thank you.